Hello class, this is our second video on chapter 9. What we're going to be doing in this video is going through the long truth table method. I've chosen as our example from the textbook exercise 9.4 question number 8, which appears on page 321. As you can see in the top left of the screen is an abbreviated version of the instructions that I provided in PowerPoints as well as in a handout for using the long method. It might be in your interest to go and take out a copy of those instructions. In the center is the actual argument that we will be analyzing. And what we will do is, by following these rules, evaluate whether or not this argument is valid. So let us begin. First, we're supposed to create a column for each variable. Let me begin over here, for the sake of space. And we have the variable p, and then we have the variable q, and then we have the variable r. Now we are to go to the first premise and create columns for each of the operations. Now we're supposed to go from the most embedded of the operators to the least embedded. By that I mean those that are most tightly bound into parentheses are the ones that are the most embedded, and then move outwards to the ones that are least embedded. In this case, we're going to start off with the negations for q and p. So let us do not p, not q. And now what we're going to do is create a column that represents the next level of embeddedness of operators. So it would be the entailment from not q to not p. And then what we will do is have a column for the entire premise. Next, we move on to the next premise, r, then not q. We already have a column for not q, so all we will need to do is create a column for this premise as a whole. And then lastly, we move to our conclusion, which in this case is not r, and thus there's the conclusion, not r. And there we go, there's our table. So let us now move to the fourth of these rules. To begin, we will find the rightmost of the variables and alternate true and false one by one underneath that row. We now move over to the next column and alternate true and false in units of 2 for that variable. And then we move over to the next variable and alternate in units of 4 true and false for that variable. By following this system, we are going to generate all possible permutations of truth values for the variables. By alternating in this way, what we've done is, as you can see, in an orderly way, made sure that we have not forgotten about any of the possible permutations, nor have we duplicated any of the permutations. What we have, as you can see, is true, 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 false, true, false, true, true, false, false, and so on. All the possible permutations for these variables are listed. If you have 2 variables, you would need 4 rows to have all the permutations. If you have 3 variables, you need 8 rows. If you have 4 variables, you need 16 rows, and so on. Now let us move into the premises. To begin with, we have the not p. So quite simply, what we are going to do is negate the truth values that we see under the column for p. Now we have not q. We're going to negate the truth values that we see under that column. Now, to not q, then not p. We're going to follow the rule for the conditional. And the rule for the conditional is, if the antecedent is true and the consequent is false, then the conditional is false. In all other cases, the conditional is true. Don't get confused. We don't need to go back over to the columns that represent the variables themselves here. Instead, since what we have is the statement not q, then not p, the antecedent is not q. and the consequent is not P. So we look to not Q, we see that it's F. We look to not P, we see that it's F. And once again, given the rule for a conditional, that rule being the conditional is true unless the antecedent is true and the consequent is false, we have the value true. Same thing here, we have the value true. Next, we have true for the antecedent and false for the consequent. So the value then for the conditional is false. Again, we have true for the antecedent and false for the consequent. So the conditional is false. Now we have true again, true again, true again, and true again. Let us now move on to the next column. The next column is a conjunction between this column and P. So, given the rule of conjunction, a conjunction is true only if both conjuncts are true. We find those rows where both this is true and P is true, and we would list those as true for the conjunction. All of the scenarios we would have, as you see, false. In all these, although not Q then not P is true, P is false. So this, move on to the next column. R then not Q. So we're going to be looking here at the R's and the not Q's. Once again, given the rule for the conditional, here we have the antecedent true and we have the consequent false. So we have false as our first line in that column. Here we have false for R and false for not Q. That gives us true. Here we have true for R, true for not Q, true. False for R, true for Q, true. True for R, false for Q. So we have false, false for R, false for not Q. That's true. True for R, true for not Q. That's true. And lastly, false for R and true for not Q. That's true. Once again, conditional is such that it is only false if the antecedent is true and the consequent is false. So we have two instances where that applies. Finally, we have the conclusion, not R. And quite simply, we reverse the truth value for R. We reverse the truth value for R as seen here in this row. And at this point, what we are going to want to do is now step on to rule number 6. Find rows to see if there is one where every premise is true and the conclusion is false. So where are our premises? Let's identify them. Here's a premise statement, right? Here's a premise statement, right? And here's our conclusion. And we can really ignore all the rest of this at this point. What we're going to look for is a scenario where both premises are true and yet the conclusion is false. What do we see here? That's true, but that's false. So that's not going to show invalidity. That's true and that's true. Well, the conclusion's true in that case, so that's fine. And in all these other instances, this premise is false. And so we have no scenario in this argument where all the premises are true and the conclusion is false. It follows, therefore, that this is a valid argument. It's a valid argument because it's impossible for the conclusion to be false if all the premises are true. An invalid argument is one where it's possible for the conclusion to be false if all the premises are true. We can identify the invalid if it's the case that we would have in our cells a scenario where for the same row we would have true for all the premises and false for the conclusion. Since we have no such scenario in this table, we can therefore conclude that this argument is valid. And that ends this video.